All right, so let's say we have a curve C, and C is given by the vector function where the x component is e to the t plus e to the minus t, the y component is 5 minus 2t, and t is between 0 and 3. Observe that y as a function of t is decreasing, so we see that clearly C is traced exactly once as t progresses from 0 to 3. Now the length of C is then the integral from 0 to 3 of square root of the following quantity. So the first quantity here is the derivative of x with respect to t squared. So the derivative of this x is e to the t minus e to the minus t, and then we have to square that. And the derivative of y with respect to t is negative 2, so we have to square that here. So then we get this integrand here that we need to integrate. Now one can simplify this integrand to the quantity e to the t plus e to the minus t, and the integral from 0 to 3 of that can be shown that is equal to e to the 3 minus e to the minus 3. So now let me explain how do we go from this integrand to this simplified integrand. Now the integrand that we have here is e to the t, the root of e to the t minus e to the minus t squared plus 4 here. So let's start with that. So if I start with this quantity, then I can expand the square, and if I expand the square, I get e to the 2t minus minus 2 plus e to the power minus 2t plus 4. Now minus 2 and 4 will reduce to 2, and so we get this. Now e to the 2t is the same as e to the t squared, and e to the negative 2t is the same as e to the negative t squared, and then the 2 here can be written as e to the 2 times e to the t times e to the negative t. And the reason for rewriting 2 in this way is that we can apply this factoring formula here, that a squared plus 2ab plus b squared is equal to a plus b squared. So so what this is telling us is that if we have the sum, which is the square of a number plus the square of another number plus twice the product of the two numbers, then that can be written as the square of the sum of the two numbers. And so here, if I think of e to the t being a, e to the negative t being b, then according to this formula, then we get e to the t plus e to the minus t squared. So this quantity that I have then is equal to this. So if I take the square root of this, so if I take the square root of e to the t minus e to the minus t squared plus 4, that's going to be equal to the square root of this guy, which is e to the t plus e to the minus t. So that's how we are simplifying the integrand as e to the t plus e to the minus t. Once we get that, then the integral of e to the t plus e to the minus t is equal to the integral of e to the t plus the integral of e to the minus t. The antiderivative of e to the t is itself. Antiderivative of e to the minus t is negative e to the minus t. So now we plug in 3 and 0, and then we subtract and we simplify. And if we do that, we end up with e to the 3 minus e to the minus 3. Okay, so then we see that the length of the curve is indeed given by this quantity. Okay, so I'll stop the video here, and in the next video we will be looking at the length of a curve given by the graph of a function.